Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers AQA Higher Tier Paper 1 Non-Calculator. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it.
Question 1a. Circle the highest common factor HCF of 4x squared y and 8xy cubed. Okay, so what we need to do here is pull out every factor that appears in both expressions. Now I've got 4 and 8 in my expression, so 4 is common to both, so I'm going to pull out a 4. I've got an x squared in one and an x in the other, so x is common to both. And I've got y in the first and y cubed in the second, so y is common to both. So my answer is 4xy. Okay, question 1b circles the lowest common multiple of 4x squared y and 8xy cubed. Now I can do this by pulling out every factor that appears, every prime factor that appears to its highest appearing power. So I'm going to rewrite these first as, well, 4 is 2 squared, isn't it? So let me just rewrite that as 2 squared x squared y. That's the first term. And my second term, 8xy cubed. Well, 8 is 2 cubed x, y cubed. So now I've got all the factors appearing the same. We're going to pull out every factor that appears to the highest power that it appears. So I've got 2 squared in the first expression and 2 cubed in the second. So I'm going to write down as 2 cubed. I've got x squared in the first and x in the second, so I'm going to write it down as the highest power that appears, which is x squared. And I've got y in the first expression and y cubed in the second, so I'm going to rewrite that as y cubed. Okay, so my lowest common multiple of these two terms is 2 cubed x squared y cubed. Now 2 cubed is 8, so I'm going to circle the 8x squared y cubed term there, that one. Right, for which acute angle does sine x and cos x have the same value? Now you need to know all of your sine and cosine common ratios from 0, 30, 45, 60, 90 for all of sine, cosine and tangent. And if you've done that, you'd remember that those two have the same value for 45 degrees. Question 3, circle the gradient of the straight line 4y plus 3x minus 1 is equal to 0. Now we can read out the gradient of a straight line from its formula as long as it's in the form y equals mx plus c. So y equals mx plus c is the format we're trying to look for. Now we don't have that at the moment, but we can rearrange this so it is. Let's move the x term to the right hand side and the constant to the right hand side as well. So I'll get 4y is equal to minus 3x plus 1. Change sides, change signs. And then cross multiplying this 4, so bringing it down to the bottom half of the right hand side, I'm going to get y equals minus 3x plus 1 all over 4. Now I can break that into two separate fractions. I can say that's minus 3/4 of x plus 1/4, dividing both parts of my sum by 4. So now I've done that, you can quite clearly see what the gradient of x, gradient of this line is. It's the coefficient of x. It's minus 3/4, so it's that one there. Question 4. A circle has radius 6 centimeters. Two diameters split the circle into 4 sectors as shown, and we're told that the area of sector A, the ratio of area of sector A to the area of sector B is in a ratio of 1 to 3. So for every one part you've got here, you've got 3 parts here. Now you'll notice that A and C are vertically opposite, as are B and D, so also this must be 1 part and this must be 3 parts. Okay, so altogether we've got 1 plus 3 plus 1 plus 3 parts, which is 8 parts. So then part A is going to be 1/8 of my circle. Okay, so area of sector A is going to be 1/8 of pi r squared. Now we're told that r was 6 centimeters, so it's going to be 1/8 of pi 6 squared. 6 squared is 36, so that's 36 pi over 8, which I suppose we can cancel down, can't we, to 9 pi over 2, or 4.5 pi. I'm going to leave it like that, 9 pi over 2. Question 5. The table shows information about the times for 100 people to complete the task. So we can see that this group frequency table goes from 0 up to 20, but we're told the actual shortest time was 3 minutes 40 seconds, and we want to work out what the greatest possible range of times is. So we know for sure that the lowest value is 3 minutes 40, but the largest value, so that we'll need in order to find the range, we're only given as a grouped value, so somewhere between 15 and 20. So we're going to have to assume then that our maximum value is going to be at the upper end of this group. So the greatest possible range is going to be our largest value, which is 20, minus the smallest value, which we're told is 3 minutes and 40 seconds. So 20 take away 3 minutes 40 seconds is going to be 16 minutes and 20 seconds. So 16 minutes 20. Now part B says, Jack says the median time is exactly 10 minutes. Give a reason why he must be incorrect. The median time is exactly 10 minutes. Well, the median value is the time taken by the middle person, and if I've got 100 people, then the middle person is going to be 101 over 2, isn't it? It's the 50.5th person. So where do they lie in the data set? Cumulative frequency tells me that my first 17 are in there. 17 plus 28 is 38, 40, 45. So that category goes up to 45. And then the next group goes from 46 up to 78. So my 50.5th value is going to be in that range, in the 10 to 15 category. So you can see that t has to be greater than 10 and less than or equal to 15. So it cannot be exactly 10. It's got to be slightly more than 10. If it was exactly 10, it would be in the group below. So we can say that the median lies in the 10 to 15 category. So must be greater than 10. Using ruler and compasses, construct a triangle ABC so that BC is perpendicular to AB. AC is 9 centimeters, and the first line has been drawn from us. Right, so first thing we need to do is construct a right angle at B so we can draw our second perpendicular line BC. Now, in order to construct a 90-degree angle, we need to Well, we need to extend the line a little bit beyond B so that we've got something that we can cut with an arc. So let's just make AB a little bit longer. And then using our compasses, we're going to make 2 marks either side of B that are equidistant from each other. So just making sure we don't change the aperture. Next, we're going to have to do some arcs above, but before we do this, we need to make sure that the gap between the compasses is a little bit wider than it was before. And then put it in one of your marks from before. Draw a short arc above B. Switch to your other mark and draw a second arc so it crosses your first. You can now draw a line from B going up, and this line will be 90 degrees from the line AB. There we go. Now we don't know how long this line is going to be yet. To work out the tip of the triangle, we're going to have to get our ruler out again. This time we're going to change the aperture of the compasses so it's exactly 9 centimeters. Like that. Then put in the tip of the compass in A. Draw a short arc which just cuts my new line. And at the point where it crosses, that will be the point C. Okay, now I've found C, I can simply join A to C with my ruler. Remember to leave your construction marks visible, and you might want to use your ruler and protractor just to double check your 90-degree angle and the length that you drew. Question 7. A bag contains 20 counters. 10 of the counters are red, 8 are blue, and 2 are yellow. 3 counters are taken out at random. If all 3 of these counters are the same colour, what is the probability that the next counter taken out of the bag is yellow? So we're talking about the 4th selection here after 3 selections have already been made. Now, if 3 selections have been made and they were all the same colour, then they couldn't have been yellow because there are only 2 yellow ones to select, so you can't have picked 3 yellow ones out. So that implies that either it was 3 reds or 3 blues that were selected. Now, in terms of this problem, we're just interested in yellow or not yellow. So there are 2 yellow counters in the bag. So we're saying 3 of the not yellow ones must have been drawn out, which leaves 17 counters altogether, of which 2 are still yellow. So the probability that the next one is pulled out is going to be my 2 remaining yellow counters out of my 17 counters in total. If all 3 of these counters are different colours, what is the probability that the next counter taken out of the bag is yellow? So if all 3 of these counters are different colours, so that means you must have 1 red, 1 blue, 1 yellow then. Okay? And in one order or another, doesn't really matter. So what's left after I've taken out 1 red, 1 yellow, 1 blue, then I've still got 17 counters of which to draw, and I've got 1 less yellow to which to draw from. So then the probability then is going to be my remaining 1 yellow counter out of my remaining 17 counters to select from. So it's 1/17. Question 8. List the integers that satisfy both these inequalities. I've got 2x plus 7 is less than 0 and x must be greater than minus 10. Right, let's take that first one. First of all, 2x plus 7 is less than 10. Rearranging that, I know that 2x must be less than minus 7, and dividing both sides by 2, I know that x must be less than minus 3.5. 0.5. Okay? Now, because x is a whole number, that means that x must be less than or equal to -4. So x can be -4 or -5 or -6 all the way down to, well, x has got to be greater than -10, so it means it must be greater than or equal to -9. So it can be any value between -4 and -9. So my answers are -4, -5, -6, -7, -8, and -9. Question 9. We're told that y is directly proportional to x, and we've been asked to complete the table. Now, if y is proportional directly to x, then y is going to be equal to k lots of x, where k is some constant that we can find. Now, we've got a pair of values that go together here. When x is 7, y is 63, so let's sub those in. So when x is 7, y is 63, so 63 is equal to k lots of 7. So that makes k equal to 63 divided by 7, which is 9. So our full equation is y equals 9x. So now very simple to fill out the rest of the table. If x is 0, then 9x is 0. If x is -8, then 9 lots of -8 is -72. All done. So we've got another table of values for question 10a. This time we need to complete the values for y equals x squared minus 2x. So we're taking the x value, we're going to square it, and then we're going to take off 2 lots of the x value. Let's start at the positive end. When x is 3, x squared is 9. Take away 2 lots of 3, take away 6, 9, take away 6 is 3. X squared is, if x is 2, then x squared is 4, take away 2 lots of 2, which is 4, gives me an answer of 0. Those 2 are given. And then if x is -1 squared is 1, take away 2 lots of -1 is +2, isn't it? So it's 1 + 2. Give me the answer 3. You can see that's kind of symmetrical around the point -1 in the middle there. So that gives me confidence because we know it's going to be a parabola. Right, so draw the graph next. Now we need to plot those points on. So 3, 3, 2, 0. So 3, 3, 2, 0. 1 - 1, 0, 0. 1 - 1, 0, 0. And then finally -1, 3. -1, 3 up there. Okay, so it's quite a shallow parabola that we've got here. Let's draw it on. Try and make it a nice smooth curve passing through the center of each of your points. Right, write down the coordinates of the turning point of the graph. Well, that's that point there, isn't it? So 1 - 1. 1 - 1. John is drawing a quadrilateral. The length of each side is 5.2 centimeters to 1 decimal place. Complete the error interval for the length of one side. Okay, so I tend to do these with a number line to start off with. I mark the point I've been given, 5.2, and then I use the rounding amount to mark on my scale the next one up. So if I'm going up in 1 decimal places, the next one up on my scale will be 5.3. And the one below it will be 5.1, and then I consider all the values that are going to round to my given value. That's all the numbers that are halfway between 5.1 and 5.2 will round up. That gives me a lower bound of 5.15, and the ones that round down are going to be halfway between 5.2 and 5.3, which is 5.25. So they're my 2 boundaries of all the values that round to 5.2. So the length needs to be bigger than 5.15 and less than 5.25. Complete the error interval for the perimeter. So we know that each of the sides are going to be between these 2 ranges. So the smallest possible range of the perimeter is going to be 4 lots of my lower bound, and the largest is going to be 4 lots of my upper bound. So 4 lots of 5.15 is going to be 20 point, what was that, 20.6? So 5.15 is probably a good idea to write down the calculation that we're doing. Examiner's not a mind reader. And then my next one, 5.25 times 4 is 20, it's just 21, isn't it? Okay, so my range is going to be 20.6 to 21. Question 12a, we're given a linear equation to solve. 2w minus 3 all over 6 is equal to 4. So first step, let's cross multiply that 6. So 2w minus 3 is going to be 6 times 4, which is 24. Let's move the 3 over to this side. So 2w equals 24 plus 3, which is 27. And then let's divide through by 2 next. So w is equal to 27 over 2. So w is 13.5. Okay. Part B, got a quadratic this time. 4x squared minus 25 is less than 0. So let's move that to the other side first. 4x squared is less than 25. Next, let's divide through by 4. So x squared is less than 25 over 4. I'm just going to leave it like that for now because I've just noticed I need to square root next. So taking the square root of both sides. It's handy to leave it like that because they're both square numbers. So finding the square root then of 25 over 4 means that x is less than 5 over 2. Now don't forget that when you've got a square root, you often get another solution as well, which is the negative version of it. So I could have x is less than the square root of 25 over minus 4. And don't forget also that when you divide an inequality by a negative number, you're going to flip the inequality sign around. So we could end up with another solution, which is x is greater than 5 or minus 5 over 2. So x is less than 5 over 2 or x is greater than minus 5 over 2, which we can combine into one result. We can say that x is less than 5 over 2 or greater than minus 5 over 2. So it lies somewhere in that range. So quite a tricky one, that. Now an alternative approach might be factorising it into 2 brackets instead of doing what I did up there. So an alternative way would be to write it down as 2x plus 5 and 2x minus 5 using the difference of 2 squares. 12c, we've got another equation, this time in y, that we need to solve. So I'm going to start off by cross multiplying that up there. So I'm going to get 1 is equal to 5 lots of y minus 6. Removing the brackets, I'm going to get 1 is equal to 5y minus 30. So moving the 30 to the other side, I'm going to get 5y is equal to 31, and then dividing through by 5, I'm going to get y equals 31 over 5. Okay, question 13a, we earn our second mark of the paper for knowing our exact trig values. The value of cos 60, of course, is a half. And then 13b, we're going to go on to use that, I think. So I've got a triangle here. It's a non-right angle triangle. So we're going to be using the cosine rule here because I've got 2 sides and an included angle and I want a third side. So let's label up the triangle. So this is my side B, so that there at the top must be angle B. So let's just call the other 2 sides, other 2 letters, that must be A and that must be C. So then writing down the cosine rule in terms of B, I've got b squared equals a squared plus c squared minus 2ac cos b. Now, I don't know which way you've remembered it, but you should be able to reformulate it for any given side. You just have to swap these a's, b's and c's around in there and follow the pattern. So b squared equals a squared plus c squared minus 2ac cos b. We can now sub into that all the values that we know. So a is 5, so 5 squared. C is 8, so 8 squared minus 2 lots of 5 lots of 8 times cos b, cos 60. So 5 squared is 25, 8 squared is 64, subtract 2 times 5 times 8, 2 5s are 10 times 8 is 80. And cos 60 we said earlier was a half. So 25 and 64 make 89, subtract 40, which is 49, isn't it? And the square root of 49 is 7 as required. Right, question 14. Tins of dog food are sold as follows. They're either sold in single tins, where there is a multi-buy option for when you buy 3. They come in packs of 6, which again has a multi-buy option for 2 or more. And you can buy them in packs of 12. And we need to work out the cheapest way of buying 21 tins. Okay, now there are quite a lot of different combinations that are possible here. Let's just think it through. Let's call this one A. And A's come in lots of 1. This can be pack size B, which is a pack of 6, and C is a pack of 12. So how many different ways are there of forming our 21 tins? Now I could buy 1 pack of size C, that give me 12 tins, and a pack of size B, which would give me 18 tins, and then 3 A's. That's one way of doing it. Or I could buy 2 packs of B, which would give me 12 tins, plus I could buy 9 single A's, or actually I could buy 3 packs of 6, which would give me 18 tins, plus 3 single ones. Are there any other possibilities? I could buy 1 6-pack. I'm not sure that's a great idea. Plus, what's that, 15 single ones? Or I could buy 21 single ones. But also, it might work out cheaper if I buy more tins. So sometimes that is the case at the supermarket. You end up buying more and it comes out less. I'm going to just check what the cost is of buying 2 packs of 12, so 2 C's, and also I could do that with my B's. I could also buy 4 B's, or I could even buy 1 C and 2 B's. That would also give me 24 cans. So I think it's worth checking those out as well. So let's evaluate all of those then. So 1 C, 1 B and 3 A's. So a pack of 12 is 550. 550 plus a B, which is 350, plus 3 lots of, well, 3A is a special offer, isn't it? So if I've got 3A, that's equal to the price of 2 tins, which is £1.60, isn't it? So 3A is going to cost me £1.60. So altogether, 550, 350 and 160 gives me a total of £10.60. Okay, that's my first choice. Now second one, 2 lots of B and 9 lots of A. So multi-packs of in size 6, if I buy 2, then I get them for £5. So 2 lots of B is £5. So 2 B's would be 5 plus 9 A's. That would be 9 lots of, well, That's 3 lots of 3A, isn't it? So it's going to be 3 lots of £1.60 then. So 3 160s, 320, 480, £5 is £9.80. So it's a little bit cheaper. It's cheaper so far, £9.80. Now, next option, 2Bs plus 3As. So I could buy 2Bs for £5. So if I want 3Bs, I'm going to have £5 plus £3.50 for my third B, plus 3As, that's £1.60. So what's that? £8.50, £9.50, £10.10. So that's a bit more expensive, that one. Or I could do 1B and 15As. 1B is £3.50 plus 15As. That's 5 lots of 3 cans. So 5 times £1.60. 5 160s are 8 plus my £3.50 is £10.50. So again, that's not cheaper. 21 lots of can A, which is 7 lots of the special offer. That's 7 lots of £1.60. Okay, 7 lots of £1 is £7. 7 lots of 60p is £4.20. So that comes out to £11.20. So that's not the cheapest way. Or I could just buy 2 big packs of the 12. So how much is that? That's 2 lots of £5.50. So again, that's going to be not the cheapest. That's £11. Or I could buy 4 lots of B. Okay, 4 Bs is 2 lots of £5, isn't it? So that's £10. Not bad, that one, but it's not quite the cheapest. 2 lots of £5, which is £10. Or finally, I could do 1 of the 12 packs at £5.50 and 2 lots of B, which would be £5. That comes out as £10.50. Okay, so I've worked out a few combinations there, and we can see that the cheapest one is this one here. That came out to be £9.80. So what is the cheapest way? It's 2 6-packs and 9 singles. And it came to £9.80. Question 15. 60 people take part in a quiz and the graph summarizes their score. Now you can see we've been given a cumulative frequency curve with all the marks on it. And we're asked to use the graph to estimate what fraction of the 60 people scored more than 30 marks. Now here's 30 on my graph. Now to work out how many people scored more than 30, first off we need to look up from 30 along our graph. So I'm going to use a ruler and show that. It's going to mark on reading up from 30. It's a good idea to show your work in this way because it counts as method, and then along from there, and I can see then that what mark is that? Each one of these little squares is worth 2, isn't it? So 10, 12, 14. It's halfway between 14 and 16. I'm going to say that's 15. So I'm going to say that 15 people scored 30 marks or fewer. Now if we want to work out how many scored more than 30, then actually what we're looking for is the people from there to there. So the number of people there are between the mark 15 and 60. So I would estimate that as 60 take away 15, which is 45 people. So writing that as a fraction, for some bizarre reason this is asking for a fraction, so 45 60ths of the people, which I suppose we can cancel down to 3/4 of the people scored more than 30 marks. Okay, part B. Estimate the median score. Okay, now the median score is at the halfway point. If you've got 60 people, then the median is going to be 60 plus 1 over 2. It's the 30.5 value, which we can read off from our graph again. So coming back to our graph, we need to read across from, well, 30.5, but might as well just read across from 30. So again, reading across the graph in the other direction this time. So along from 30, and then change direction, go downwards. Now I estimate that to be just slightly below 70. I'm going to say that it's 69. So estimate the median score, 69. For now. Question 15C. The same people take part in a second quiz. The graph summarizes their scores for both quizzes. So we've got our original curve quiz 1 and our new curve quiz 2. Jack states the quiz was easier than the first quiz because the graph is higher. Does the graph support this statement? Give a reason for your answer. Now, though at first glances it might appear that people would have done better at quiz 2 than quiz 1, that's not actually how cumulative frequency graphs work, that the higher the graph is, the better that you're going to do. Now let's consider what we just did, finding the median value. So if I read off at 30 for both tests and find out what the median is for both of them. So we've got two values that we can look up here. So the median for the second test is there, look. And for the first test or quiz, it was up here. We said it was 69, didn't we? So we said this one was 69. Now we can see that the median for quiz 2 is all the way down here. It's 19. So on average, people did a whole lot worse on quiz 2 than quiz 1. So was quiz 1 easier? I would say no. The median for quiz 2 was 19, much lower than quiz 1. Question 16. A toy box contains red, yellow, blue and green bricks. 25% of the bricks are red. There are 12 yellow bricks. The ratio of yellow to blue to green is 2 to 3 to 1. Show that there are 48 bricks in the box. So we've got some, four related facts that we need to try and work out. Okay, let's start with the known fact that there are 12 yellow bricks. Okay, so y equals 12. Now we know that the ratio of yellow to blue to green is 2 to 3 to 1, so that means we can work out those at least. So yellow to blue to green is 2 to 3 to 1, and we know that we've got 12 yellow bricks. So scaling up our ratio by a factor of 6, we should be able to find out the number of blue and green bricks as well. So 3 times 6 is 18, so there are 18 blue ones. And 1 times 6 is 6, so there are 6 green ones. So how many bricks is that altogether? So 12 plus 18 is 30, so we've got 36 bricks, which are either yellow, blue or green. Now we're told that 25% of the bricks are red, so our 36 bricks which are yellow, blue or green must be the rest, the 75% or 3/4 of the bricks. So 1/4 is red, which means that 3/4 are not red. So 3/4 of my total, 3/4 of the total is going to be 36. So then the total is going to be 36 times 4. 36 times 4 divided by 3. 3's into 36 go. 12 times 4 is 48. Total is 48 as required. Right, question 17a. We've got laws of indices question. Work out the value of 8 to the minus 2. So whenever you've got negative indices, you can treat that as a whole separate step actually. So the minus sign is one operation and the 2 is another operation. So whenever you've got a minus negative index, it means 1 over that same positive power. So 8 to the minus 2 is the same thing as 1 over 8 squared. And I know that 1 over 8 squared is 1 over 64, so that's my answer there. Question 17b, solve 4 to the power of x is 8 to the power of 2/3. Okay. Let's try and make the bases the same for both these numbers. 4 is the same thing as 2 squared, so 2 squared to the power of x is equal to 8. Now 8 is 2 cubed, so 2 cubed to the power of 2/3. Okay, so when you've got an index and an index like that, you multiply them together. So that's the same thing as 2 to the power of 2x is equal to 2 to the power of, what's 3 times 2/3? That's just 2, isn't it? So 2 to the 2x is equal to 2 to the 2. So then equate in our indices, because the bases are the same. These two bases are the same, look, they're identical. So it means I can equate the indices. So 2x must be equal to 2. So x is equal to 1. 17c, simplify the root of 3 to the 0 times 3 to the 1 plus 3 to the 2. Okay, so what we've got here then, well, 3 to the 0, anything raised to the power of 0 is 1. So I've got 1 times 3 to the 1 is just 3, plus 3 squared. 3 squared is 9. So I've got 1 times 3 plus 9. 3 plus 9 is 12. 12 times 1 is 12. So that's equal to root 12. Now 12 is equal to 4 times 3. So I can break that up into root 4, root 3, and the root of 4 is 2. So that's 2 root 3. So there we go, 2 root 3. Question 18. Here is a velocity time graph of a car, and we're asked to estimate the distance travelled in the first 10 seconds. Okay, so distance travelled is the area under a velocity time graph. So we need to estimate the area under the graph between 0 and 10. So we want the area under the graph to the left of this line. So we want this area in here. Now you can see that it's got a curved edge, which is not very helpful, but we can estimate the area by creating an approximate area that is similar to our original area. So if we put a straight line between there and there, we can estimate the area to be the area of that triangle. And obviously it's going to be slightly less than our true area, but it should be reasonably accurate. So area is approximately equal to that triangle, half base height, which is going to be half the baseline, which is 10, times the height of the graph at that point there. Was that 45? So 45 times 10 is 450, divided by 2 is 225. So I'm going to estimate it to be 225 meters. Question 19. In this question, all lengths are in centimeters, and we're told that the triangle and the trapezium are equal in area. Work out an expression for y in terms of x, given that the sine of theta is equal to 1/3, and give your answer in the form y equals a over bx, where a and b are integers. Okay, so we've been given a triangle. We know two sides algebraically, and we've been given the angle and the sine of that angle. So we're going to use the sine formula for the area of the triangle. So area of our triangle, well, the formula is half AB sine C. Okay, but in terms of this particular triangle, that's going to be half of our two sides. That's 6x and 8y times the sine of theta. And we're told that sine of theta is 1/3. So that is, well, I've got half times 6 times 8. So half of 8 is 4. 4 6s are 24. So 24xy. And the sine of theta we said was 1/3. So 1/3 of that. 3's into 24 go 8 times. So that is 8xy. Okay, next let's have a quick look at the trapezium. Now the area of a trapezium is equal to a half a plus b h, where a and b are your two parallel sides and h is the distance between them. So a is 10x, b is 4x, and h is 3x. So that's going to be half of 10x plus 4x times 3x. Is that right? Yeah. So 10x plus 4x is 14x, divided by 2 is 7x, and times by 3x is 21x squared. Okay, so now we're told that these two areas are equal to each other. So area of my triangle is equal to the area of my parallelogram, which means that axy must be equal to 21x squared. Now what are we looking for? We're looking for y in terms of x, so we need to make y the subject here. So cross multiplying the ax part over here, then we get y equals 21x squared over 8x. So cancelling that x with that x squared, and can I cancel down top and bottom? Nope. 8 and 21 don't have any common factors, so I'm just going to leave it like that. So y equals 21x over 8. Question 20. Here are 6 cards. Now we've got 3 A's, 2 B's and a C card. And we're going to pick 2 cards at random from here. Assume that the first card chosen is not replaced. Work out the probability that both cards are B. Okay. Now whilst there are 3 different types of cards, for as far as I'm concerned, we've either got 2 types. We've got the card is B or the card is not B. So I'm going to group them together like that. So is the card B or is it not B? So how many B cards are there? There are 2 out a total of 6 for the first selection, which means there are 4 not B cards out of a total of 6. And then for my second selection, I'm gonna, if I picked B the first time, I'm gonna have 1 B card left out of a total of 5. And if I didn't, to pick B, and if what's the probability of not picking B? Well, I've still got 4 not B cards out of a total of 5. So my probability of pulling a B at my second selection, given I didn't pull B the first time, I've still got 2 left, haven't I, out of a total of 5. And if I didn't draw a B on the first selection, my probability of not drawing it on the second selection would be 3 out of 5 there as well. Right, so assuming that the first card chosen is not replaced, work out the probability that both cards are B. We're interested in this route here, along there and along there. So then the probability of B b is equal to 2/6 times 1/5, which is 2/30. Now I could cancel that down to 1/15, but actually you don't get any extra credit for probability questions, so you might as well just leave it as 2/30. Right, in part B it says, in fact the first card was replaced. How does this affect your answer to part A? Okay, so if it was replaced, then I will still have 2/6 there, won't I, for the second selection. My probability of B followed by B is going to be 2/6 times 2/6, which is going to give me 4 out of 36. Now, comparing my two fractions, which is bigger, 4 out of 36 or 1 out of 15? Well, 4 out of 36 is the same thing as 1/9. So, which is bigger? So, 1/9 is much bigger than 1/15, so the probability is now bigger than it was. 1/9 is bigger than 1/15. Question 21. Circle any fractions that are equivalent to 0.36 reoccurring. Okay, let's see if we can convert this first off. Let's let x equal to 0.36 reoccurring, which is 0.36, 36, 36, etc. Then 100x is going to be 36.36, 36, 36, etc. So then subtracting the first from the second, I'm going to get 99x equals 36. So x equals 36/99. So that one is certainly equivalent. Now does it cancel down, 36/99? Yes, actually they do. 36 and 99 have a common factor of 9. So I could cancel this down to 4/11. So that one is also an answer. Question 22. f of x equals 2x squared and g of x equals x plus 5. Circle the composite function f g of x. So that's where we're taking g of x and substituting it into f of x. So we're going to rewrite this where we see the x above. So f g of x is going to be 2 lots of x plus 5 all squared. So it's that one there. Question 23. The diagram shows a right angle triangle which is 4 centimeters along one side and 6 centimeters along its hypotenuse. 4 of these triangles are used to make the shaded square below. Work out the area of the shaded square. Okay. So I think what we need to do is we need to know what the third side of our triangle is, and in order to do that we need to use Pythagoras theorem. So if this is side C, A and B, then B squared is going to be C squared minus A squared, which is 6 squared minus 4 squared. 6 squared is 36. 36 minus 16 is 20, so B equals the square root of 20. So that's root 20. So then how far is it from there to there then? So from here to here we know is 4, because it's the shorter side of my triangle, and so this side here must be root 20 subtract 4, and then so the area of the square is going to be root 20 subtract 4 times itself. So area of square is going to be root 20 subtract 4 squared, because you can times it by itself. So let's just double that bracket out. Root 20 minus 4 root 20 minus 4. So, and do FOIL on it. So root 20 times itself is going to be 20. Then I'm going to have minus 4 root 20 minus 4 root 20. And then minus 4 times itself is plus 16. So 20 plus 16 is 36, and minus 4 root 60, minus 4 root 20 and minus 4 root 20 make minus 8 root 20. Now we need to give our answer in surd form as simply as possible. So can I simplify root 20 any more than it already is? Well, a 20 has got a square factor in it, it's got a 4 in it, so I can rewrite that as 36 minus 8 lots of, well, that's 4 times 5, and the square root of 4 is 2, so I can take 2 out of the surd, so that's going to give me 36 minus 16 lots of root 5. Now I could factorize that as well, but I'm not sure it makes it any more simple than it already is, so I'm going to leave it as it is. So 36 minus 16 root 5. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.